Good morning, folks. How's it going? This is another video on Precalculus, and I am Mike coming back at you with that video. In the previous video, we just touched on some final properties and a particular way in which we can look at the 6 trig functions. In this video, we're going to take a look at the graphs of our trig functions and see what these things actually look like. So let's get right into it with the graph of sine of x. The graph of sine x or sine theta, whatever, is at the left here. You see that it has a very wavy pattern. It starts at the origin, and then if you go to the right from there, it goes up to +1, back down to 0 when x is pi, down to -1, and then back up to 0 when x is equal to 2 pi. So it follows that cycle, 0 up to 1 to 0 to -1, back up to 0. And this pattern keeps going on and on and on. You can take this chunk right here and just copy and paste it over and over, going that way, as well as going backwards this way, and you'll come up with the rest of your sine function. Now think back to the previous video when we said that the sine function had a period 2 pi. And we said, what did it mean for a function to be periodic? It meant that the outputs you get, the sequence of outputs that you get from your function is going to repeat over an interval of length p, and that p value is your period. So this is why we say that the period of the sine function and the cosine function, which we'll see shortly, is 2 pi. Because you see over this interval of length 2 pi starts at 0, up to 1, down to 0, down to -1, back up to 0. And that cycle of values repeats over the interval of length 2 pi. So that's why we say that the period of the sine function and the cosine function is 2 pi. If you think about the sine function as the vertical distance up and down, specifically the y-coordinate of a point on the circle of radius 1, if you think about it as you move counterclockwise on that circle, you start at the point 1, 0. You're going up to 0, 1. You're then going down to -1, 0, then down to 0, -1, and then back up to 1, 0. So if you take those y-coordinates of those points, 0, 1, 0, -1, 0, if you picture taking a point on the circle of radius 1 and moving it around the circle in a counterclockwise fashion, then you'll see why this sequence of values makes sense as well. So I want to talk about some of the transformations we can do with the graph of the sine function as well as the cosine function and the terms that are associated with these things. So as we said, the sine function has period 2 pi, but it also has amplitude of 1. And in general, what the amplitude is how high up or how far down does the function go from its center point. If you picture, in this case, with just sine x, if you picture the x-axis as the middle of it, you see that from that center point, if you will, we're going up 1 and we're also going down 1 from it. So that's the amplitude there. How far does our function go up or down from the center, in quotes, of that graph? And note that the cycles here, the sequences of repeating values, they start at x is equal to 0. Now, what's the most general type of trig function we can see? It's something of this form. F of x equals a times the sine of the quantity bx minus c b is always going to be a positive number there. Now, what does this function have in terms of amplitude and period and something called a phase shift? For this guy right here, the amplitude is the absolute value of a. We specify that it's the absolute value of a because sometimes a is less than 0, and that has a different impact on the graph of our function. For this thing here, the period is 2 pi over b, and then the phase shift, which is just changing where the cycles start at, the phase shift is by c over b. And if c over b is positive, then the shift is to the right. If it's negative, it's to the left. You can think of the amplitude as sort of a vertical stretch or compression. You can think of the period sort of as a horizontal stretch or compression, and then the phase shift you can think of as a horizontal shift. If a is negative, then this function will be reflected over the x-axis, which means instead of starting to go upwards, it's going to start by going downwards. So it would go down to -1, up to 0, up to +1, and then back down to 0. Here's the graph of the cosine function. It also has that same wavy pattern. I just sketched this over the interval -4 pi to +4 pi, but you could keep doing this same pattern over and over, and you would get the rest of your function. Again, the cycles do start at 0. We start at +1, go down to 0, down to -1, back up to 0, and then back up to +1. That sequence, that cycle of values, again, happening over an interval of length 2 pi. And if you think about this guy, again, as the x-coordinates of the points on your circle of radius 1, then this makes sense. Start at 1, 0, x equals 1. Go up to 0, 1, x is 0. Keep going to -1, 0, x is -1. Down to 0, -1, x is 0, and then back up to 1, 0, where x is 1. Also, note that if I just took this function, the sine function, and I shifted it over to the left by just a little bit, I would get exactly the cosine function there. So with a little shift of the sine function, we can get the cosine function. Likewise, if I shifted this guy right just a little bit, I would get this function here. That all has to do with that whole co-function property that we talked about earlier on in this chapter. And it works the same way with the cosine function as it does with the sine function. The general cosine function, a times the cosine of bx minus c, has amplitude absolute value of a, period of 2 pi over b, and phase shift c over b, again, where b is positive. And if c over b is positive, then the shift is to your right. So what you guys should be able to do is, if you are given a sine or cosine function that looks like it's in any one of these two forms here, you should be able to identify what's the amplitude of the function, what's the period of the function, and if there is a phase shift, what is it? So let's do some sample problems there identifying those three things. So I have 3 such functions here. For each of these, we are going to identify the amplitude, the period, and the phase shift. So first one here, f of x is 4 times the sine of the quantity 5x minus 2. The one thing that can really help you out is to just identify what are A, B, and C. Compare A times the sine of bx minus c to this thing right here, and just match pieces up. A, B, and C. So here I have the number in front of my trig function, that's my A value. Here, the number that is in front of my variable x, that's my B value. And then the number that comes afterwards is my C value. Now, again, note that in this standard format here, it's bx minus c. So if you're seeing a minus sign here, like we are in this case, then your C value is going to be positive. If you're seeing a plus here, then that means your C value is going to be negative. But amplitude was the absolute value of A, so the absolute value of 4 or 4. Our period was 2 pi over B. We said that our B value was this number right here, so it's 2 pi over 5. And then the phase shift, if we have one. Again, the phase shift was C over B. We said that our C was positive here, and obviously that number is 2. So it's going to be a positive 2 divided by 5. So our phase shift is a positive 2/5. Now, what is this actually saying in terms of the graph? If we had to describe what this sine function looked like, we could say that this is a sine function who goes up to positive 4 and down to a minus 4. It's still centered, if you will, on the x-axis, but it goes up to positive 4 and down to a negative 4. The fact that our period is 2 pi over 5 says that it's going to take an interval of length 2 pi over 5 to go through one cycle of values, or one sequence of values of the function. And then the fact that our phase shift is 2/5 says that these cycles, or our cycle is going to start at x is equal to a positive 2/5. And from there you go up to positive 4, down to 0, down to negative 4, back up to 0, and you do all of that in an interval of length 2 pi over 5. Here's another one here. Negative 3 times the cosine of pi x minus 1. Again, if you need to, underline and highlight and label what are your A, B, and C values. Amplitude, the absolute value of the number in front of your trig function. So absolute value of minus 3 is equal to positive 3. The period, 2 pi over B. B is the number that's in front of your variable x. So I have 2 pi divided by pi, or just 2. And then phase shift. Once again, if there's a minus here, this number, your C value, is going to be positive. If there's a plus sign here, your C value is going to be negative. So it's going to be a positive 1 divided by my B value, pi. So if you had to describe this particular cosine function, again, it's centered on the x-axis, if you will. It's going to go up to positive 3 and down to a negative 3. The period of it is 2, which means it's going to take an interval of length 2 for this cosine function to go through one cycle of values. And the cycles, if you want to sketch them, start at the x value 1 over pi. So I have a third one here. Try this guy on your own. Figure out what is the amplitude, the period, and the phase shift. So press pause. When you think you have the answer, press play, and we'll see if you're correct. Okay, so let's see if you came up with the correct answer. Hopefully for the amplitude, you got a positive 9, the absolute value of the number in front of our cosine here. The period was pi over 3, 2 pi over 6, and then the phase shift was a negative 5/6. It was a negative 5/6 because this is a plus here, which means our C value is negative. And if you had to describe this cosine function, again, it's centered on the x-axis, if you will. It goes up to positive 9 and down to negative 9. It's going to go through a cycle of all its values over an interval of length pi over 3. And those cycles are going to begin at x equals minus 5/6. So these were just a few samples here where you had to identify the amplitude, period, and phase shift. You should be able to take this information and then use it to at least describe what a trig function looks like, if not being able to actually get some sense of a sketch of the function itself, basing that sketch off of the graphs of sine x and cosine x here at the bottom. Now there is one more feature that we could have inside of a general trig function. You could see something like this. You could have some constant added on or subtracted on to the end of your function. That plus d there, that is just a vertical shift that will move it up from being centered on the x-axis if that guy is positive. It'll move it down from being centered on the x-axis if that d value is less than 0. It doesn't impact the period. It doesn't impact your phase shift. It doesn't impact your amplitude as well. It just changes where the thing is centered at, and you can, and it's just only shifting it up or down. So let's look at the graphs of the other trig functions that we have. The graph of tan x looks like this guy here. We have these clear cycles happening here, and we have vertical asymptotes happening. As we said from our previous video, the period of the tangent function is pi. The domain, all real numbers except odd multiples of pi over 2. The range is all real numbers. And those odd multiples of pi over 2 are where we have vertical asymptotes because they make the bottom equal to 0. Again, keeping in mind, tan is sine over cosine. Odd multiples of pi over 2 make cosine of x equal to 0. This is an odd function. An x intercept occurs midway between each pair of consecutive vertical asymptotes, namely all whole number multiples of pi. So 0, pi, 2 pi, minus 2 pi, so on and so forth, going both ways. We can do a similar type of thing with figuring out the period and the phase shift. We don't really so much concern ourselves with amplitude when we're talking about the tangent function because it's just not really something that we focus on that much. The a value there in this formula here, that would just be stretching out each of these cycles here. Picture these guys being pulled away, up and down there. And then the bx minus c piece, that is used to determine when you have consecutive asymptotes, vertical asymptotes happening between bx minus c equals minus pi over 2 and bx minus c equals pi over 2, or just any any pair of consecutive vertical asymptotes in general. Don't worry too much with all the technical transformations we can make. Don't worry about amplitude and period and phase shift so much with the tangent function. Worry about that more for sine and for cosine. I do also want to show you the graphs of cotangent, cosecant, and secant. Cotangent looks very similar, sort of, to the graph of tangent, but in this case, it goes the opposite way. For tangent, those cycles were going up, now they're going down, and they're shifted over just a little bit. For cosecant x, we have u's and upside down u's happening here. Once more, the sequence of outputs occurs over an interval of length 2 pi. And what you would find if you sketched the graph of sine x on the same set of coordinate axes, you would actually find that it would look something like this. And the two functions would touch where they have the u's or the upside down u's. So seeing both those at the same time is just a little visually pleasing. And this is a sketch of the graph of secant x. Again, period of 2 pi. Just like cosecant, if you sketched the graph of cosine x, you would get that similar kind of pattern there. You can also take this guy, shift it over just a little bit to your right, and you would come up with the graph for cosecant x here. But I really just wanted you guys to see these graphs. I feel that you should see them. Don't worry with amplitudes, periods, phase shift. Again, that's all just for sine and for cosine. So guys, this concludes my video on the graphs of our 6 trig functions, as well as determining amplitude, period, and phase shift for sine and cosine, and being able to talk about what those things are actually doing to the graph. In the next video, we are going to get into inverse trig functions. Yay, a lot of fun there. So if you have any questions or comments, please be sure to reach out to me, guys. Send me emails, send me texts, send me postcards in the mail, flare signals, SOS bonfires, whatever you have to do. Otherwise, until the next video, take it easy.